Can AI help me to build better in Minecraft? That is the question I set out to answer in what started as a small weekend project, and then, very predictably, spiraled into something much larger than expected. Because look at this. This is what I can build in the forever creative world I play on with my daughter, a deeply uninspired brick house. It has walls, sure, it has a roof, technically it is a shelter. Emotionally, it is a cry for help. Artistically, it is a crime. Meanwhile, my daughter is out there building imaginative castles, rainbow bridges, cozy little houses, and whatever else a 7-year-old can come up with. So I thought, wait a second, I work with AI. Surely I should be able to take the tools I use in research and somehow use them to become less embarrassingly bad at Minecraft. That led me to the real question. Can AI agents build in Minecraft? And if so, which one is actually the best? Spoiler, it's Gemini. But before you close the video and go back to scrolling, come along with me, because the route to that answer is much stranger than I expected. This project started a couple of months ago, after I saw a Reddit post and a few posts on X about two mysterious stealth models that had appeared on OpenRouter. They were called Healer Alpha and Hunter Alpha. Hunter Alpha in particular caught my attention. It claimed to have a very large context window, support for vision input, strong performance in agentic workflows. I had already been thinking about using large language models to play around with Minecraft building, and because these models were free to use at the time, it seemed like the perfect excuse to try. Now, for anyone curious, those models are no longer available in that form. It was later revealed that Healer and Hunter Alpha were Xiaomi models, now known as V2 Pro and V2 Omni, and they moved to a paid format. Now, that was already my first hint that this project would not just be about Minecraft, it would also be about how quickly the model landscape changes. To be clear, I am very much not the first person to combine Minecraft and AI agents. The YouTube channel Emergent Garden has gone much further in this direction, including videos on AI agent building, fighting, and generally doing strange things. There are also projects like Agentcraft and Molding Minecraft on GitHub, and of course, the fantastic Voyager, which tries to build a fully game-aware agentic AI system inside Minecraft. So my goals here were much more modest. I did not want to build a full Minecraft player. I did not want an AI client that logs in, walks around, turns its head, and sees the world through a camera. I wanted something simpler, an agent that can directly call tools exposed by a server plugin with a focus on building. So the plan is we'll use a simple Python-based plugin running on a paper server. We'll expose a small set of Minecraft building tools, keep the agent inside a bounded build area, and then see which model produces the best structures. Now, the reason that this is a Python-based plugin rather than the normal Java as you would expect is simply because I had already been working on a Python interpreter system inside of Paper. So I could write plugins in Python, similar to the plugin LuaLink if you know about that one, whilst still having access to the Bucket API. There is no deep reason it has to be Python. A normal Java plugin could offer the same thing to an agent. Python just made iteration faster and it made it easier to expose a live coding tool to the LLM, as we will see later. The first version of this system was built around a very simple idea. Give the agent a small voxel box and a handful of tools. The agent does not need to be a Minecraft player, it does not need to move around, it does not need to survive, it just needs to build. Now at first, because Hunter Alpha was supposed to be good with vision, I thought it would be clever to give the model visual feedback. I did not want to capture the actual Minecraft window and move the player around as a camera. Instead, I decided that everything could just be rendered server-side. So I created a material whitelist and an according color mapping. For each allowed Minecraft material, I assigned a simple RGB color. Stone is gray, cobblestone is slightly darker, mossy stone bricks are a bit green, and so on. And then the server could inspect the build region, convert the blocks into colored pixels, and render simple PNG views. As such, the basic non-visual tools were getBounce, which tells the agent the size of the build area and the origin, getRegion, which inspects a cuboid region and returns the materials inside it, getBlock, which checks one block at a relative coordinate, and setBlock, which places a block. And finally fill, which fills a cuboid region between two coordinates. Then I added the vision tools. There was a tool to render a top-down view, a side view from a cardinal direction, a sliced view alongst one axis, and an isometric view. The idea was that the agent could inspect its own build visually, notice what was wrong, and then improve it. Now, for humans, these views are actually quite useful. You can glance at a tiny isometric render and immediately see, oh well, yeah, that's a house, or no, that roof doesn't make any sense. Here you can see a couple more examples, and these images were generated by Pillow by looping over the blocks, mapping the materials to colors as we saw, and adding some basic shading. Now, especially the isometric view is a little bit crude, but still readable enough. It gave the model a visual summary of the world without needing a real camera. Now, looking back though, I think that this was a slightly naive assumption, and hence why I later decided to move away from this. Humans are extremely good at interpreting these visual shortcuts, but LLM agents, even vision-capable models, are still much better when the state is textual, structured, and explicit. They can reason over images well enough, but mapping a rendered PNG back into exact Minecraft coordinates and then choosing the right tool calls to correct their mistakes is still hard for many of these agents. Now that said, the first attempt still worked better than I expected. Moving on to the prompt then. The core prompt consisted of 5 parts. First, a system prompt tells the model that it is a Minecraft build agent operating inside a bounded relative voxel box. Second, the prompt included the allowed material whitelist. In the early Vision version, this was a strict whitelist because only whitelisted materials had colors for the renderer. Third, the actual user request is inserted. Something like, I want you to build a cute cozy starter house or build a medieval castle. The agent also receives info about the bounds, the size, and the origin as set by the user. Fourth, the agent receives a live status suffix. It is told how many steps it has already taken, how many blocks it has changed, whether there are still cute edits being applied in the pipeline on the server. And this queue matters because the server should not just freeze because an agent decides to fill half the world in one go, so hence we apply edits in a queued fashion. Finally, there were warnings, the most important one being added after I noticed that some models would spend their entire turn thinking, planning, inspecting, without ever deciding to build. Now, if this happens, the next prompt then basically interjects this reasoning and says, you have exhausted your inspection budget, your next move should use a build tool, not just an inspect tool. Sounds a bit blunt again, but I found that these small edits to the prompt mattered a lot for many of the models that I tested out later on as well. With this setup, I ran some early experiments using Hunter Alpha and a few simple prompts. These initial results, as you can see here, are not amazing, but they were nevertheless promising. The agents understood the rough idea of the user wanting to build a cozy cottage or to build a tower, so they're pretty good at boxing stuff in, building walls. They are okay at adding roofs, at understanding how crenellations and windows and so on should work. So all in all, this was promising as an initial result. They tried to place chimneys, sometimes they placed lanterns, doors, windows, and so on. So they had clearly some spatial understanding of what a Minecraft build should look like. Here you can take a look at a couple of additional very early examples. In the background you see some other early attempts at trying these models out, showcasing kind of the same style of builds that they were going for and the same style of mistakes that they made. Now, it's not always perfect. They did place blocks on top of lanterns, they put doors in a doorway and then later on override their own edits. They would make interiors that kind of look fine on the outside, but were not really usable from the perspective of a Minecraft player. Now, after a day or two of playing around with this and trying out different builds, I was kind of wondering, well, what if I expand the scope of the model selection a little bit? And can we figure out if there are not only differences in quality between models and their capability to build, but also differences perhaps in their personal style? So I settled down on a basic prompt that I absolutely wanted to test out, which was build anything you want, express yourself, be creative. Now, once that was settled, the next obvious question becomes, well, which model is now best at this? At this point, I went browsing through OpenRouter and I made a large list of models to test. Now, the obvious candidates here are, of course, OpenAI, Claude with their Sonnet and Opus models, Google with Gemini and Gemma. We have DeepSeek on the Chinese side, Other models like Qwen, Minimax, Kimi, ZAI's GLM, Step, Seed, many others. I expected that the biggest frontier models would dominate on this task. Upfront, I heavily thought that the bigger the model, the better it would be at building in Minecraft. So my guess was that Cloud Opus or the strongest OpenAI ChatGPT model would simply blow everything else out of the water. After all, these models are good at coding, reasoning, tool use, so surely they should also be good at building. I was wrong. Now, the first benchmark attempt was pretty messy. I settled down on a collection of the models that you can see listed here on the screen, and then went on to try to structurally benchmark these models across a variety of prompts. Here you can see this in action. You can see that here I try to manually place signs in the world. I give each model a plot to build on, and I then enter the prompt for them to start building. Now, this footage looks relatively promising at first. Here I'm trying to go for a prompt that has models build an apartment building. Now, one model indeed is going for an apartment building. Another one goes for a more towerish style, as you can see here. And then another model, and this already revealed like very early large differences in quality. I believe it's the next model coming up here, which is Biden Seed. Basically completely errors out on the task, and it's not only much slower than the previous two, but it just decides to fill up the whole structure with wooden blocks, and it basically gives up after that. I didn't want to sit around and babysit all of these models, especially with most of them taking an incredible amount of time to build. So all of the footage that you see here is heavily sped up. So I had to come up with a more structured approach. So after some initial runs, I decided upon an important decision. First of all, I had been planning to try out both a set of vision-capable models and a set of models that were not vision capable, but in the end I decided to remove the whole vision story and the rendering of isometric images completely from the main benchmark. The vision tools were interesting, but they added too much variation. Different models used images very differently, and many did not use them well. Removing the vision also meant that I no longer needed to restrict the agent to a small material whitelist, and I could instead tell it, you may use any valid bucket material names. Here are examples, and you can use more if you want to. That turned out to work much better. The final benchmark used prompts like this: a creation that best expresses your personal artistic style, personality and preferences, a cute cozy starter house, a fantasy tower, a medieval castle, a modern mansion, grand cathedral, and a haunted house. The first express yourself prompt became my favorite because it revealed something, again, surprisingly interesting, namely the fact that models do in fact differ in style. And then I added the dangerous tool on top of all of this. I gave the agent access to a new tool called Execute Python. Since the server plugin was already running inside a Python-like environment connected to the Bucket API, I could let the agent submit short Python scripts. Those scripts could then call helper functions like getBounce, getBlock, setBlock, and fill, but they were also free to incorporate things such as loops, using math, using random number generators, and also direct access to all the Bucket classes that API exposes as well. On the server side, we just build up a Python environment, and we then just use exec to directly call the Python code and execute it onto the server. Now, of course, from a security perspective, this is a terrible idea, so don't do this on your own server, but for testing out, this was okay. Before coding mode, an agent had to place blocks one tool call at a time, or use relatively simple fills. Now with this coding mode, it could generate a whole structure procedurally. It can make circles, spirals, hedges, towers, patterns without spamming a whole lot of independent separate set block or fill tool calls. You're essentially saying, hey model, here is my local Minecraft server, please go ahead and execute arbitrary Python code inside it. Now again, to be very clear, don't run this on a real public server. My setup was a local client connected to a local server. If the agent broke something, fine, it's just breaking my little own test world or it's crashing the server, so what? Now as an experiment, this mode was fascinating. I didn't expect that the models would be good at this, but the best models immediately became much better. They fully leveraged the power that was granted to them, and they stopped placing one block at a time and started writing little construction scripts. So what did the benchmarks reveal? Well, here you can see a couple of the, let's say, more impressive builds. This is an example of one of the haunted mansions, as you can see here, where the models indeed are pretty good at placing pumpkins, signs. It's all done relatively correct. In the background, you can see a couple of less nice looking examples from other models. Here you can see one of the modern mansions that isn't looking too badly. Even here the interior makes more or less sense. So I also thought that this was a relatively impressive result for an LLM that just has access to a Python environment. But also here you see kind of some examples of structures of please try to express yourself. So the example that you see here in front is a typical example of what a ChatGPT would do. They love glowstone, they love the frog lights. On the left of that, in the background, you see a more Quen style solution. And on the left of that, with all the white and the purple, that's definitely a Google Gemini style of expression. Gemini loves to use white and purple and goes for galaxy-based constructions. So here is where I started to notice the interesting kind of self-expression differences between the models. Here you can see one of the more organic shapes that, for instance, Kimi likes to produce instead. So this is a more treehouse style looking building that we have here in front of us. On top of this, in this whole kind of overview, you can also spot in the background that many of these builds look horrendous and are basically just blocky shapes. So there are vast differences in capability and quality of what these models can produce, even when all of them have access to executing Python and that execute Python tool. So a lot of models actually failed quickly, or it was clear when I constructed my final very subjective comparison, looking at quality, speed, and the cost of running these models, that some of these models can just simply be discarded on the basis of all three of these. There are some models in there that I thought would be interesting, like the ByteDance model, or using things such as Inception, which uses a non-transformer based setup. Gemma, very nice models in terms of speed, but they got stuck in the tool calling. They didn't understand the tools and the tool arguments and the tool results well enough. There are some models that do a little bit better in terms of quality. So if I would have to make a selection at this point, these were the two that I withheld: Gemini 3 Flash Preview and GLM5 Turbo. And then we went back through the drawing board. We took a look at some other generations between these two models. I ran another playful test, which was suggested by my daughter, which was to build a girly looking mansion. And Gemini, which you can see in front here, built something clean and constrained. It has a pool, a garage, cherry-style trees, glass panes, lots of small details, and a layout that looks like it can almost function as a real Minecraft building. It's not perfect, the build area is a bit tight, but it understood the assignment. GLM, in the background here, also built an impressive looking mansion. It used loopsalt in Python to place hedges and details, and from the outside it looks very ambitious and lively. Now, the one additional problem with this model is that at some point the models should call a finalize tool when they want to indicate that they want to stop and provide a summary, but they also get access in their status to how many steps or blocks they have still left to change. And GLM never wants to finalize. And here is another result to look at. Here is also Gemini showing off that even in longer conversational forms, it's actually doing quite well. Here I ask it to construct a beautiful tree of life, which it's doing very well, but for some reason, due to a Python error, the trunk, which is supposed to be there in the middle, didn't end up being placed correctly. Now the model believes that there is nothing going wrong, so it doesn't inspect the actual tree trunk. So then in a second follow-up, I basically tell the model that something went wrong with the tree trunk and that it should go back, inspect it, and see if it can correct its mistake. What you can also notice here is that the leaves that it has placed, most of the models do not realize that the leaves need to have a certain distance to wooden blocks for them not to decay. Virtually none of the models are basically aware of this out of the box. Now, I know that there are Minecraft builders who can make this kind of thing easily. I cannot. If I had to build this tree myself, I would actually have been proud. Now, just when I thought that I had finished the video, this was the time when new models started to appear. In particular, we had the release of 4 large models coming from China, GLM 5.1, which I was eager to try out because that AI, as we saw, already did quite well. Kimi 2.6, Qwen 3.6 Plus. Now, none of the Qwen models really impressed me in the previous selection, and there are so many of them, but okay, why not give it another try? And of course, DeepSeek version 4, and also in particular the Flash version of this. DeepSeek wasn't doing too badly, DeepSeek version 3 in the previous round either, so I was also curious to see what, how this would, or how well DeepSeek would do. Now here I basically ask all of them to build a creative build expressing their creativity, their personality, and their skills. So the first model is Qwen. This had disappointed me in earlier runs, but in this case, 3.6 is doing much better. It started using Python more effectively. It's making circles. There is a tiny error there, as you can see. It's making spirals. It used glowstone, frog lights, a spiral case, so that's looking very nice. Kimi, the one that you can see here, also produces a very pretty build. It has a better sense of space. It's even, again, going for something more organic-like. It's making a pond, it's making a crown of glowstone, and it's adding lots of interesting natural details. So also, compared to even the results that Gemini Flash was giving me in the previous round, I did find that this new generation of models, let's say, suddenly had become much better at building in Minecraft. I mean, look at this. This is looking quite impressive here. And here is the end result. Also, DeepSeek was extremely eager. It's writing clean Python loops. It also loves to show off by creating circles and spirals. It is producing something structured and deliberate, so very DeepSeek in the sense that it felt precise and almost diagrammatic. Also a huge improvement compared to the previous version 3 version of the same model. So also this, a quite clean but impressive result. Very retained, using its tools to the best of its capabilities to add lots of small details. This is a clean looking wizard tower, you could say, or magical tower, much better again than the previous version. And then finally we have GLM 5.1, still having this kind of element that it loves to continue to add details. It's moving quickly, it's producing a lot. So let's take a look at what this is going for. Also, this one is picking a magical wizard tower. A lot of these models, if you ask them to just build something on their own, they will go for wizard towers. So hey, also this is not looking all that bad. So at this point I was thinking, fine, conclusion of the video. I like Gemini, it's fast, it works well. But hey, these 4 new Chinese models, what you know, actually, they also do a very good job and they produce very incredible results. In the time span of a couple of months, the story so far of this video was going to be more about, well, good luck benchmarking these models at one point, because a month or so later, their capabilities have improved dramatically. So also here you can see that GLM does not really want to stop. It's adding more water cascades, more lights. It sees that it still has room, so why not some pinkish blocks, removes them, put archways in. I like GLM in the sense that it's very eager to continue and adding and more details until it again starts to screw up the build a little bit. It didn't have to go that far. It looks at, I have this many blocks remaining, so why would I finalize? But in terms of detailing, it has its own style and it's doing a pretty good job as well. So this leads us to the conclusion, right? Well, not really, because a couple of weeks later, even newer models entered the picture. What would you know? There is Gemini 3.5 Flash, Qwen 3.7 Max, and a high 3 preview from Tencent that a lot of people were playing around with. That was a real surprise, as we will see. So I couldn't help myself, and I also had to compare these 3 models with one another, especially because I already had seen that Gemini was doing such a good job, so I was eager to see what its follow-up would do. So this is Tencent High 3. Now this actually is a real surprise. This model was capable to build fast, and it's making, as you will see in a second here, a colorful circular structure using the colors of the rainbow. very impressive, being very creative here. It's adding water, it's adding gold blocks, orange blocks, wool, a rainbow like pedestal. Very impressive actually that this model combines or has its own or goes with a very kind of colorful, friendly design. So you can, and it's also very fast. You can see that it's having fun here. So I was definitely impressed by what this model is producing here. Again, by making use of a Python script that it's running. So again, this felt like, again, another, let's say, iteration of models becoming much better at their task. Now, next up here, we have Quen 3.7 Max. You see that it still has the Quen-ish love for, what is that, polished granite and glowstone. For some reason, all the Quen models love polished granite and glowstone. But it also improves in its capabilities. It's expressing itself much more clearly than before. It has a way better understanding of the tools that it can use, of the bucket API that it has access to. It has a better spatial understanding as well. So compared to the initial Quen models that I had in my benchmark, this is a way better improvement. Its material selection, it's a bit Quen-ish, a little bit boring, I should say. But okay, at least spatially, it all makes sense this time around. Gemini 3.5 Flash was still excellent. Fast, clean, textured, spatially coherent. I mean, see what it's trying to go for here. It's trying to make some cave structure. It feels surprisingly comfortable inside the Minecraft world. It uses coding tools well. It produces builds that look like intentional Minecraft creations. This was also an LLM that I saw understanding or really debugging issues that it faced with this weird Python interpreter that I had set up, and really understanding why its imports are not working, because it realized I'm probably in some sort of weird JVM kind of environment here. I'm trying to use the bucket scheduler, but for some reason that's crashing. So yeah, if we take a look again, if we take a look at what we end up with here, I think that at the end of the day, my personal favorite in terms of speed, quality, build variety, what you can do with it, that Gemini 3.5 Flash is my favorite model. Now, I know that meanwhile also Claude has come out with their 4.8 line of models, which also are actually doing quite well. I've also been playing around with these models, but by now I had already spent about $200 on OpenRouter comparing all of these models. So it was time to call this, weekend project, to call it a day. So conclusions. Yes, agents can build in Minecraft. The interesting question is, why are they so different? Bigger LLMs, generally they're more capable, but it's not necessarily that there is a direct correlation between a model having more parameters necessarily being better at Minecraft. What I also found is that the prompting matters a lot depending on the LLM. Some LLMs, especially like Gemini again, are very good at understanding the kind of environment that they have been placed in. And even although the prompt is not very specific, will kind of reason on their own and take a little bit of leeway to try to debug and so on. Now, giving models access to more tools, this was a maybe expected but nevertheless surprising result in a way, gives better results. Don't try to craft a manually curated selection of build tools to offer to your LLM. If you have a way to give them full-on server access, let's say, or bucket API access through Python, or CLI access as we're seeing nowadays, they like that. They like being given full access and trying to figure things out on their own. Also interesting to see were the large differences in speed and quality. Not just quality, but also speed. Some of these models are extremely slow. That might be an OpenRouter thing or a caching thing. I don't know. But also there I saw a lot of differences. And there were, and this was the most pleasing for me, there are interesting differences in style and preferences. Now, this benchmark is not at all scientific. This is not a rigorous leaderboard, but it also reveals kind of interesting things that normal benchmarks might not always show. And finally, most importantly, newer models keep getting better. This project took a couple of months and I had not planned for this at all. Even during that short period, the reason that it took so much is because during that short period, my results kept changing as I kept updating the plugin, the prompts, and I kept seeing that newer models started to show up at the OpenRouter leaderboards and seeing that they were doing a much better job, I basically gave up on always repeating the full benchmark with all the prompts and having to wait around for hours for them to produce their builds. Just a quick tests with the newer models and having them be creative and build something already verified that basically the models that were released, or the 4 models, the 3 models that we saw later on, basically blew that whole initial leaderboard out of the water altogether. If the current pace continues, I suspect that by the time that I finally do publish this video, again, half of the results that you see here will be outdated. Now, what are my plans going forward? If possible, at some point, I would like to release the code for this. I have been thinking to maybe automate this setup to keep a leaderboard, but I know that I'm way too lazy for that. And then maybe if I have some time later, I would like to return to this and improve the prompt, improve the tool schema, maybe see how newer models continue to improve if you give them access to a Minecraft world, and seeing what they can do. Thanks for watching, and see you later.